All right. Welcome, everybody. Since we're waiting for the people to join, I will start with the announcements. Yeah, welcome for the May 2022 edition of our shared meetup between iOSoho and DC iOS. Tonight, oh, wait. Yeah, before I get into tonight's topics, I would like to welcome you all. As you can see, again, this is yet another virtual meetup co-organized between DC iOS and iOSoho. Very quickly, a few notes, a few words about our meetups. iOSoho is a New York City-based meetup. We typically, at least before the pandemic, used to meet once a month, and we had 2 technical talks, and we kept this format online, and we're very much looking forward to going back in person. But even when we do, we'll try to keep like the online presence as well. I'll pass it to Scott to talk about DC iOS.
Hey, good afternoon, everyone. So my name is Scott. I am one of the co-organizers for DC iOS, and we're glad to have you all again. I don't know what we have planned coming up for next month after this one. We will probably still be virtual, but I guess keep an eye out. We will probably try to have some sort of lightning talk or some sort of other post-dub thing. But in the meantime, we're glad to have you all here again one more time.
As you can see, you're all muted for now, but this will change at the end of the meetup. We'll be able to like unmute and go into a networking session. In the meantime, feel free to use the chat for comments, questions you might have. And we are recording. We try to record every meetup and post them on our YouTube channel, which Scott will share in the chat at some point. Tonight, we have 2 great presentations planned for you. Ed is going to start with talking about bridging the divide, the gap between Unity and SwiftUI. And Florian will talk about like how to work with GraphQL in iOS, I guess. And what is GraphQL for you, those of you who might not know. It's a very interesting technology for sure. At the end of the talks, on top of a couple Q&A where you can all like ask questions and unmute, we'll have a networking session. For those of you who are familiar with the meetup, we have done that for the past couple of years, where we do breakout rooms in Zoom and get a chance for everybody to join in, and we'll have like themed rooms. So 2 of the rooms will be themed after or named after the presentations for tonight, and then we'll have one probably for hiring for those of you who might be either looking for a job or looking to hire, and we'll have a general room as well for all of the topics. Before we get into those great presentations, we're going to reverse the usual order of things. Today we're going to start with announcements and then go into the presentations. Usually we do it the other way. Let's see how this goes. So announcements. First of all, next month's meetup, I kind of alluded to it very briefly. For those of you who were here last time, we were supposed to do today's meetup in person at OkCupid in New York City. For logistical reasons, we had to push it a little bit, but the great news is it is still on, it is still happening, and happy to share that next month, a couple of weeks after WWDC is over, we will have a in-person meetup at OkCupid, the first time after over 2 years. And it will be a lightning talk special. If you have been to our WWDC specials in the past, those are short format, 5 to 8 minutes. And we have more presenters. Like typically we have 2 talks at iOSoho and DC iOS. And in this one, we'll have, I don't know, depending 5 to 10, depending on what the topics are. On that note, quickly, we have a YouTube channel and a Slack community. Scott, if you don't mind sharing the links in the chat, that would be great. You will find the recording for this meetup and previous meetups as well. Back to what I was saying before, we have WWDC lightning talks happening next month. We don't know what the topics are going to be, obviously, because it's all going to be fresh topics. And for that reason, we don't know either who are going to be the speakers. This is a call for speaker. The same way we're looking for speakers for our main events for longer presentations. We're also looking for speakers for this special. So if you're interested yourself in giving a public talk and a smaller, shorter version of a talk, please reach out to us. You can use this form. The QR code, the link below are working. You can sign up, put your name, your email, what you would like to talk about. If it's something you already know, please fill in the form. If you just are interested in speaking at the WWDC special, you can also use the form. For sure, you don't know yet what you'd like to talk about, or maybe you do, and then you can like fill in as much information as you'd like, and we reach out to you for further questions and organization. You can do it right now, or you can save the link and do it as soon as the WWDC starts. Maybe the State of the Union is going to give you an idea of what you'd like to present on. Anyways, you get the idea. If you would like to talk, now is the time. This is the form. And like I said before, please stay connected at the end of the sessions for a little bit of networking. That's all for the announcements for today. Scott, do you have anything else to add?
Nothing for me.
Awesome. Well, in that case, I will stop sharing and pass it to Ed to talk to us about the bridging SwiftUI and Unity.
Okay. I assume you can see that?
Yes.
Okay, good. All right. Yeah, I can't see anybody else, but I can just see my charts. Okay, so let's see. I'm at Arenberg. I've been a developer for ever, and been doing iOS development since about 2008. I'm a small company. We do contract work for small startups, individuals, all the way up to some Fortune 100 companies. And always looking for another gig. So if anybody has a lead, always happy to hear it. What you're going to see here came out of some work we were doing with the Toyota Mobility Foundation. And we're building basically a mobility assistance platform for them. And this is what you'll see. Some work came out of that, so we were able to extract it. Hence the date's a little older. We're mostly doing this work in Android, unfortunately, but we did do an iOS prototype just to show that the bridging process actually works and we can make it all work the way we want it to. So let's dig in. Unity, for those not familiar, it's a very popular 3D platform. You can do 2D with it, but it's mostly used for 3D development systems. And back in 2019, they introduced a process whereby you can export the Unity project as a library. And that gave them an official way to embed that library inside of a native app. Prior to that, there were a bunch of hacks for doing it, but in 2019, they made it official. However, that process that they generated exports basically an Objective-C++ app, which presents a couple of integration challenges if you want to go to something slightly more modern. And of course, SwiftUI, it's all the new compositional, reactive framework, all the hotness from Apple these days. Basically the way forward for Apple. So I think Apple's done a good job with integrating SwiftUI with all the existing UI kit and Swift frameworks and such. But by doing that, they've abstracted away a bunch of key pieces that you really need to go integrate with something like the Unity library export. So we're going to kind of go through some of the challenges you have to overcome in order to make those two work together. So why would you want to go through all of this? Well, Unity is a great 3D platform, great look, but it has a real problem with all the look and feel for user interactions, buttons and menus and alerts and things. And so, at least for our app and perhaps for yours, we wanted to provide a more native experience for the users. And SceneKit, it's kind of old. It's not really being updated a lot, and it's a single platform solution. So we felt Unity was going to be more appropriate for the things that we were building. So if we can make the two work together, we get the best of both worlds. All right, so what we're going to build is basically a simple app that starts with a SwiftUI view, and then there's a button there to launch into the composed experience, where that'll transition to this bridging code that we're going to write that integrates a view controller with an app delegate to hold all the code that talks to Unity, and then layer on top a SwiftUI view to handle all the user interactions. And here's what you see. So I tap the button, it generates the views and layers that on the scene. And then it provides a layer as well for communicating between the two layers so that both sides can talk to each other. So for the Unity export as a library, there's a nice example that Unity provided. It is a little dated, as I noted, but it does provide the basics of how you put the app together. And you can start their example, run it, you can get something working, but it's again going to be an Objective-C app or C++. So we're going to try to figure out how to make that a little bit more modern. A couple of things to note: Unity renders full screen. So even if you want to embed it as a component inside your app, you can't. It's really going to take over the entire screen, and you just have to deal with how you want to layer your interface with that. The raw export is about 100 megabytes. So it's reasonable sized, but as soon as you start to layer your assets and stuff on the 3D environment, it can definitely grow from there. The example also provides the basics on how you generate a workspace to integrate both the native code and the Unity library code. And the basic steps they kind of talk about, which is create the workspace, you put your stuff at the top level, you add the Unity framework to your native project, expose a couple things as headers, and move your data folder over. It's just some boilerplate stuff. You do most of that once, and then thereafter, every export just works. So if you continue to update in Unity, you don't have to go through these steps again. But there is at least one step that you run into some problems with, because they kind of rely on the fact that you are writing C code in order to integrate the Unity framework. And here's where our SwiftUI troubles kind of begin. So some of those, just to note, for example, is they expect you to have access to the main function. So to grab arguments that would be passed into a C program that then can be passed down to the Unity library. Also, the app that they provide is Objective-C or Objective-C++ technically. And if you want to integrate SwiftUI inside of it, there's no UI hosting controller to wrap your SwiftUI views inside of. So we're going to have to play a few Swift tricks to kind of wrap that for us so that we can vend that out to the Objective-C side. All right, so we got our workspace set up, and that was basically most of the boilerplate stuff that came from the example that Unity provides. Let's go take a look at the code that we're going to have to write. So we'll start at the top, and our initial view is a SwiftUI view where we just have a link. It's a navigation link, and that will take us over to our Unity view. That Unity view is really just a wrapper for our controller. So not too much there in the initial SwiftUI side, but then we'll dive into what the UVC view looks like. So in there, that'll take us to a UVC, which will be a UI view controller representable. And that'll allow us to wrap our Objective-C view controller inside of that, as well as it will host an app delegate. And we'll go into the app delegate in a little bit more because we need access to things at the app lifecycle layer. That app delegate we're going to write a little function to initialize Unity. And it will call something called Unity Framework Load. That is a utility provided by Unity as part of their library export that will handle the basic initialization of the Unity experience. Once you have that, then you can grab that view and do whatever you want with it. So in this case, we're going to stick it inside of our hosting controller. And that will at least get the basics of Unity up and running. So the UVC, a very simple structure. It's a view controller representable that wraps my view controller. And my view controller is where we're going to write all of our Objective-C, C++ code to handle the Unity layering of the views. And in my view controller, so when we load that up, we're going to do a couple things. One, we're going to get access to an app delegate. We'll look at the app delegate structure a little later, but we're going to create it and hold on to it because we're going to need to make use of it later. And in this case, the first thing we're going to do is call its init Unity function. And that's going to be all the glue logic that gets Unity up and running. And then we're going to tell that app delegate about us so that the delegate can then call back to us a couple key functions that it's going to need to get access to. Okay, app delegate. In this code, we're going to make use of one key function from Unity, which is the Unity framework load. And first look at this is you'd say, yikes, what's all those brackets? And good old school Objective-C code, or Objective-C++ actually is what we're writing under. And our init Unity function is going to make use of that Unity framework load function that the library provides. And we will set our own instance of the UFW to that so that we have access to it, and we'll use it a couple places. This is mostly boilerplate from the example that Unity provides. So their sample code has stuff that looks a lot like this. It's mostly lifted from there. But then you get to a point where you actually want to start, initialize, and run their embedded framework. And you start to see things like they want access to argc and argv and launch options for your app. And you kind of get stuck there, go, what, where are those? How do I get that? I've never seen that in any SwiftUI environments. Fortunately, there is a way to get to it. And that is, it makes use of the NSProcessInfo class. You can get access to your environment at runtime, and you can see things like the arguments that were used to launch the application. So back in the good old C days, all apps started with a main function, and that main function got called with two arguments. One was argc, which is the count of the number of arguments, and argv is just an array of arrays, array of strings, basically null terminated strings that are the arguments that were passed into that to the program. So to get access to those, we have to reassemble from the NSProcessInfo data the NS string array that it can pass back to us, and basically assemble a bunch of C strings. And so this is some yucky C code for doing that. I'm sure there's probably another way to do it or two. Maybe it's cleaner, but this is pretty much lays out the process of creating all the pointers and all the arguments that we're going to need later. So argc, that's just the list. That's just how many arguments there are. So just count them. And then argv is just an array of pointers to null terminated strings, C strings. Okay, so now we need to also get access to one other thing, which is the launch options for the app itself. And these are the iOS launch options. In this case, fortunately, SwiftUI gives us the ability to specify our own app delegate class with the @UI application delegate adapter operator. So that will tell SwiftUI this is our app delegate, and it would like to receive app lifecycle events. In this case, we're going to look at the application did finish launching with options call and grab its dictionary of launch options that we'll pass then later on. So we hang on to that. And then in our class, in app delegate, when we want to actually run that call, run embedded with args for the Unity framework, now we have all the pieces we need to pass into it to actually get Unity initialized, the argc, argv, and app launch ops. Okay, so now we have Unity running. So if we just ran our app at this point, we would see the Unity view and it would show up in our app and we could interact with it and do whatever we want at the Unity layer. Now we want to take a SwiftUI and layer it on top of that. To get this, we basically need to create a factory method to vend out a hosting controller that will have all our SwiftUI inside of it. And then we can put whatever we want in there going forward. So here's our factory method. This is, in our case, we needed a dismiss handler for our code. It's not actually used in this little example, but it's still there. But it's just a little Swift function that will vend out a hosting controller as an object. And one key component of this is that background color. The UI view controllers all have opaque backgrounds. So if you want to see your Unity view underneath, you need to make that background clear. Otherwise, this will vend out our overlay view, which is a SwiftUI view. And at that point, you can put anything you want inside that SwiftUI view. So buttons, layers, lists, whatever elements you'd like to put on top of there. So here's all that kind of put together. So we're going to call that Swift factory. We'll create a view controller that now has our SwiftUI view embedded in it. We'll hang on to that. We're going to need it later when we want to do communication. So we'll hang on to that controller. And then we'll embed it as a child view controller into our view hierarchies. And that's pretty much rote stuff for doing that in Objective-C. If you recall, the self.viewController, we stuck that away earlier. That is that myViewController Objective-C++ class that we wrote that handled some of the initialization for the app delegate. And that view is Unity's root view that we also saved away earlier with the UFW, I think it was called, or UFC view. So we have the various pieces that we need to squash our 2 or 3 layers on top of each other. All right. And that is pretty much the structure. We now have a SwiftUI view sitting on the view hierarchy on top of a Unity view that's been bridged together by our myViewController class that holds the 2 together. So not too bad, but definitely a long road if you've never done this before, just to try to figure out all the pieces and how they communicate. Okay, well, our next challenge is how do we make those 2 layers communicate? We'd like to be able to have an action take place in the SwiftUI side, a tap or whatever user interaction we want, and have that communicate out to Unity. And similarly, when something happens in the Unity environment, we'd like to be able to maybe change our user experience on the SwiftUI side. And unfortunately, this is more standard stuff. We didn't have to reinvent anything. We have to dig into any new code. It is still Objective-C stuff, but you can bridge that to Swift as needed. And Unity does provide a layer for that communication. So to go from Unity to native, there's some boilerplate stuff you stick in your C# code in Unity, which allows you to specify functions. What function do I want to call out on the native runtime? In this case, we did an example where Unity ready is going to be called. And this just basically tells our native side of the code that Unity's finished setting up. And now you can do what you need to do on the app side, the rest of the app. So that Unity ready call will then get called out to your app delegate. And if you wanted to then inform your Swift code in any way, you'd expose a function on the Swift side that the Objective-C could call. And on the flip side, if you want to go from native over to the Unity side, it's ugly, but it's not terrible. Basically, what you're doing is you're calling a Unity framework function called send message to go with script with name. You give it a script name, which is the script that's embedded in the Unity environment that's attached to whatever object you're going to be communicating with. And you're going to give it what function name you want to call in your Unity side. And then your message that you want to send to it encoded as JSON. And that on the Unity side, you just get that message, it'll call your function, and you have to pull apart that JSON and then decode it and do what you want with it. And that's basically how you put the two together. So I'm going to show a quick little demo that has a start Unity that we saw earlier. It's going to launch up into our environment, and then that is going to present a SwiftUI view on the top that you're going to press a button on it. So the show alert is tapped. That will then communicate down to Unity. Unity will do something and send a message back to SwiftUI to say, okay, go show an alert when it's done. And while you couldn't see anything happen, that's effectively what just happened. Is again, once Unity started, I tapped on the show alert button, and that called into the Unity side. Unity then called back into Swift side and showed an alert. And with that, that's the integration process for SwiftUI and Unity. And Paul, I said it was going to take 30, but I got it done in 20. So definitely open for any questions, any comments. I'm hoping everyone actually heard all of that.
We all heard it. Thank you very much.
Okay.
If anyone has any questions, and round of applause on top. I know I do it for everyone. Nobody can unmute, but you can imagine the crowd applauding all at the same time right now. If anyone has any questions, please, you can raise your hand by clicking on the little reaction button down there and raise your hand. Wait, yeah, it says raise hand. Or you can type it, both work. I have a quick question before I pass it. Is your code available by any chance, a demo on GitHub or anywhere?
I thought about trying to sanitize it further to be able to do that. It was taken from a client project. So I stripped out as much as I could for the presentation, but I probably could get enough of it cleaned up that I could put it up there. So yeah, I can send it up on Slack later when I do.
That'd be awesome. And I can share your slides if they're shareable as well with
sure.
the rest of the group on the meetup page. We will do that after. I would pass it to Pierre, who is, I think, raising his hand. Let's see.
Yes, I am, in fact, raising my hand. Hi, my name is Pierre, and
Hi, Pierre.
I've done a lot of Unity development as well as Swift development. And I had a question for you. It has to do with the touch events. So I see that you're catching the touch events in the Swift side. Are those also getting passed down to the Unity side?
Yes, they are. Yeah, so as long as the view is transparent, it does not capture any events. So only the Swift UI layer actually ends up capturing events. So if you look at the screen that we saw earlier, I can bring that demo back up. That whole, let's see. You can still, I don't know, I guess we just lost the screen share. Sorry. So yeah, that whole lower section below the Swift UI component is interactive.
Nice, nice. Okay, great. Thank you.
Anyone else has any questions? You can write them down or raise your hand. I have a quick question, actually, if you don't mind. I don't know how much you can share, but what is the use case for you?
Sure.
For the project is?
Well, Toyota Mobility Foundation, they're kind of dedicated towards enabling mobility outside the car as their mantra. So whether it's assistive technologies, whether it's guidance technologies, whether it's informative technologies for those who need help outside of a vehicle environment. And so in this case, working with them to provide informational support for people who have mobility or mobility challenged in various environments. This is an example of somebody going to the beach, and it was going to provide access paths, information about where the facilities are that are available for them, provide routes for them so they can see them, and it was going to do it with the 3D environment so they could kind of see the map and move around it as such. There's a bunch of others that have since now been done. We worked with an amusement park in San Antonio. We worked with one of the botanic garden parks, I think it was, for how to get access around their facilities for people who are mobility challenged. So it provides a visitor experience effectively as well. And for us, we want to go beyond that, because a lot of the technology we had developed internally as well. So we want to provide visitor experiences. If you go to, say, a botanic garden and you want to navigate around it, you can look at the Google map for it, but you're mostly going to see trees. So this provides a kind of a 3D experiential map that you can then move around, and it's interactive and things are dynamic and so forth.
All right, awesome, thank you. I was imagining it would be some sort of video game, but not in that case yet. That could be some interesting stuff to do with.
Yeah, the 3D stuff's all for the mapping and for the layers that get done on top of the mapping, so that you can visualize what's going on in different areas of wherever you happen to be. So food, restaurants, interactive elements, tours, ephemeral things that are happening at your event and at your location.
Cool. Any other question, or should we move to the next? I mean, if you have more questions, there will be another chance at the end of the meetup. We'll break into breakout rooms, and Ed will have a room named after his talk, so we'll be able to ask questions over there as well. All right, well, thank you again. Thank you very much. And without further ado, I will pass it to Florian to talk about GraphQL in iOS.
Hey everyone, let me share my screen. All right, you're getting the full screen sharing experience. All right, welcome everybody to my talk, Enough with REST, Time to Work with GraphQL. A title that has been chosen specifically to get up all the people that love REST and get them riled up with GraphQL, since it's a topic that a lot of people can usually talk about. And I see I already have a couple of my colleagues here in the call, which I'm very grateful for them to be here. As we're going through transitioning from REST or adding GraphQL to our stack, I'm excited to talk about this topic here. So before we start, I want to ask in the round more or less, right? You can use the chat to reply to my question. Who had some kind of serialization issue in their app, whether in production, development, or staging before? I'm sure it's a very common topic that people have, that some kind of property that is mismatched, or there's some kind of spelling error, anything that would bring up the debugger for you, and you'd be finding that one of your keys doesn't match, and you actually end up with a serialization issue, very common issue. Who had communication issues with the backend team? I'm pretty sure there's a couple of people. In any of the jobs that I held previously as an iOS developer, I always had kind of an issue where you had a Google Doc or even a Word document floating around that was describing how an API looked like, or you were just trying to get all the different responses. So you had kind of a time where you had a hard time going through how to communicate with the backend team and how the response looks like. Or even worse, how often did you actually implement something as a REST API on your iPhone app or your iOS app, right? And you were targeting the wrong versioning, right? Happens quite often. Very common issues, and that's why we want to talk today about what we can do to REST to make it better, or to make it to the point of where we don't have these issues anymore. And one of these solutions is GraphQL that we're going to talk about today, right? So we're going to talk about REST versus GraphQL, or I don't want to say versus because I don't think they are competing against each other. We want to rather talk about REST and GraphQL and how we can enhance REST to the point of where we can like have all these issues that I've just mentioned or that are very common go away, or how we can just go and use GraphQL, which has a lot of this tooling already implemented. A little bit about myself. I'm Florian. Hi. I'm from Atlanta, Georgia. I'm originally from Germany. So I live in Atlanta, Georgia, but I'm originally, that's where you hear the accent from Germany. I've been an iOS developer since 2008. So I had to illegally bring my first iPhone from Switzerland without paying customs to Germany. It's now over the 10-year mark, so I can no longer be fined for the customs that I took there. German-American engineer, as I mentioned, my DMs are open at Caffeine Flow. I'm a staff engineer at Betterment. So I've been working with Betterment for about a year now, developing their iPhone and Android app, which are both Flutter, by the way. We are hiring, so hit me up if you're interested after this talk. There is a link at the end of this talk with a business card of myself, a PK wallet pass for you. And otherwise, you can always hit me up on Twitter. So REST versus GraphQL, or REST and GraphQL. What is the difference? We'll quickly go over like what you can tell and what you can see, like so we know what the terminology stands for. So looking at REST, this is one thing, right? So what is REST? REST, actually, the term means representational state transfer, right? So we all know REST, you have different endpoints. So you have different URLs or URIs in this case, where you have a like different endpoint that gives you a different entity, right? So you might have like a pet store that has a /pets endpoint that gives you on a get method, right? All different pets, or you can create a pet with saying like post against pets, and you would put the pet that you wanted to create into the body, right? Or you have a third endpoint where you say like, well, I want to get this very specific pet, and then you put the ID in it. But you have these three different endpoints theoretically, and then you have like also the HTTP verbs that you use. And so to get together, right, like you would create on your Swift side, on your iOS app, you would create a struct, you would say this is codable. And then because you have the synthesis that, or the synthesized properties that the Swift compiler actually has on a language level, codable, automatically synthesized, it will be able to actually compile these types automatically for you. And therefore you can encode and decode them with the codable protocol, right? So that's what your client implementation would look like. And then on the client, you need to say that like, well, I'm going to connect this response that I'm getting from the endpoint, or that I'm expecting from the endpoint, to this endpoint on the left-hand side, right? So looking at the left-hand side, the API, the REST API that we have there, right? I need to connect it to this dot, right? Or is it this dot? That's the /pets, right? So that's the question with REST. And then you have the other question of where you're like, well, is it going to be a get? Is it going to be a post? Is it going to be a Facebook API that just returns 200 and you'll be fine, right? It's a kind of like question you have with REST, but theoretically, that's how you implement REST on iOS. And then if we look at it, like you also have to select like whether is this the production API or is this the development API, and which environment do I work? So putting REST into action and putting REST all together, like your HTTP transfer that you're using on a REST API is usually like the REST request, your method plus the URI, and then you get a response back that needs to be well formed so you don't have serialization issues when you deserialize the response that you're getting from the server. And on the other way around, you also need to be like transferring basically on metadata or on like any kind of information exchange that you do with the backend team on how you communicate between each other, right? And this is the part that often breaks. So what is GraphQL compared to that, right? So in this comic, which I think is nicely like putting that together, it's like, well, on REST, you're asking, can I get the production side? The developer says, sure, and breaks out his books with all the rules and like different kind of things that like defines the REST API, the different methods, the different endpoints, what we just said, but you need this catalog, right? While in GraphQL, you ask like, can I get the production side? Sure. And the developer or the backend actually gives you just what you want because you conveyed your request through like what you wanted, right? So GraphQL, or the QL just stands for query language, which is already telling us something about like what GraphQL actually is, right? So we graph something, we try to bring like the information that we have into a graph, and then put a query language on top of it, so we'd be able to query the data that we want from the backend. So if you had a bookstore, for example, right, you know that your data looks like this. You have a book that has an ID and a name. It has an n times n relationship to an offer, because any offer or any book can have like multiple offers, but every book can only have one publisher generally, because otherwise the book would have a different string if it would be two different publishers. And so it's an n times n relation, n times one relationship. And so you can graph this into a schema, right? Which is on GraphQL, like we looked at the Open API spec or the Swagger spec for REST before. A similar thing on the GraphQL side is the schema, but this, and instead of like where the Open API spec or the Swagger spec, you would have to write manually or annotate. The schema is actually a living and breathing documentation that makes up your everything that is the GraphQL server. Without the schema, you cannot work. And so this is an integral part of the GraphQL server, right? And so you describe with the schema what different types you have, or what different like things to query, right? What different properties and types you have on your server, and what properties each one of these entities have, right? And so, for example, the author has an ID and a name, and then has multiple books, which is why you have the n times n relationship. Then your publisher has an ID, name, and has again books. That is missing in the diagram underneath, but like you have that relationship through the author, right? For the book and then for the author. And then if you look at the book, right, it has an ID, name, publisher, and an author, which through all of these different edges, you can traverse the graph in one direction or the other direction. And then going from there, right, like I said, the schema and the documentation is a living and breathing thing. Looking here at one of the more popular examples of the bookstore, which is like a very common example that you find online all through documentation, basically, you can actually look through the different edges of your graph and basically query any of these combinations that you like. So you'd actually ask the server what you want through the query that you give the server, and the server gives you specifically for your query the results back, which we'll see in a second. And so if you do that, your query might look like this, where you say like, well, I want a book with the ISBN number. And from that book, from the return that you're giving me back, which is based on the schema, right? From the schema, you know what queries you have available. And then from the schema that tells you what queries you have available, and then what tells you what entities you have available, you say like, well, I'm getting a book back. And from that book that has that specific ISBN, I want the titles and the authors. From any of these books, I want all the authors, and from all of the authors, I want the name, right? And so putting that together with the schema, because you have the type annotation, you know what you need, you can dynamically basically put these things together and be type safe. And so looking at that, that's what a graph would look like, right? For this specific query, it's a book where you get the title back. The title for the book is capital something, I forget, capital of the 21st century, I think is the name of the book. And then you get two authors back because you get a list of authors, which would be Arthur Goldhammer and Thomas Piketty, and that's the graph that you just traversed. And looking at the graph that you just traversed, right, your response that you would be getting in JSON from the server looks like this. Now, some of you might be like, well, at this point, okay, so I have everything together, but I still need to write like a lot of code. Well, you don't, and we'll come to that in a second. So putting all of this together, like this is what your playground could look like. It's pretty much like what Postman and others like other tooling is actually doing, but you can put that on your server, and it's like basically a bundled tooling that you get, the GraphQL playground. There's different kinds of like playgrounds for that. There's Graphql and other like tooling that you can use. But you can basically live test and live look at the schema. And since all of that is one big part of like what is bundled together with the GraphQL server, you can live query your server. You can live and look at what you're expecting to get back. And since the schema is the living, breathing, basically central part of the GraphQL server, you know what you can query and you know what you can expect. And therefore you can code generate basically all of these things together and be type safe at compile time. So what's the difference between GraphQL putting that together? There's a very nice comic that I couldn't spare you, or very nice drawings from Rapid API that basically just go what REST versus like GraphQL is. So the REST API is fetch data in a way that returns the whole data set. Oftentimes you build like backends for front ends where you build like one big response that is specifically measured or specifically put together for a specific screen that you have on iOS, or that you have on mobile, or that you have on web. And oftentimes that is way too much data. So often you get like specific data for like, you only need 2 objects, you only need like 3 objects. But in any case, oftentimes like the REST API ICD specific give you back 100 items. So you throw away the other 99, which is A, like you're overfetching, and B, like the other thing, like oftentimes you need to traverse very deeply into what you need, which is not per se very performant or what you like a lot. Or if you have the issue of like going through the book example that we had, right, and you need to book first, and you only have an API endpoint for book and you have one for author, you would need to fetch twice instead of the one time that are shown. And so what is GraphQL, right? GraphQL allows you the client to specify the exact data returned, what you need, right? And it has this schema definition language, SDL, where you basically define like what a type looks like and what edges of the graph you can visit how, right? Which gives you the idea of like, you can specify what data you need. And since you no longer need to rely on like, I just want to go to /pets or /books, you only have one endpoint /GraphQL, and then you can tell the endpoint basically what you need and what you want. And so REST APIs are simple to use and set up, right? Like, but it's very hard to like change them if you have a very specific use case, and then you would need to version them up. And they are client and server independent, but you need to communicate, like we've shown, all the different pieces and methods that like a REST API has. And like contract enforcement is very, very hard around REST. It's an open topic, right? So GraphQL, on the other hand, right, is centered around one API endpoint, and it's tailored to your data requirements. And oftentimes you don't need to do overfetching because GraphQL has like a very nice caching mechanism, and GraphQL, through the part that you have the introspection from the schema, allows you to go to do less round trips and do less overfetching. So I know this is an iOS meetup. That's why I don't want to make it just about the technology. So I also have prepared a part on the iOS implementation. So here's the thing, right? What is the game plan? If we have at compile time, right, our assets where we have like the schema that we could download today from our server, and we know what kind of queries we want to do. If we would put these together, right, and then we can get as a build product or as a build step, we can just generate our models, right? So we can co-generate the models of what they should look like, because we know from the schema and the query for introspection what types we're going to expect, and we know what the response will look like. And we also know like what each individual of the properties, what type they will have, right? And therefore we can generate like the models for the build product, which will give us in fact then type safety at compile time, right? Sounds wonderful. Looking even further into this, right? If we're putting this into the client, if the schema would ever change, right? And we would change our models and we relied on any of those generated models, right? Our compile time would break. Awesome, isn't it? So what would that look like actually in an example? Everybody knows Star Wars except me, because I've never watched it. But if you would look at the Star Wars example, right? Yep, I saw your face there, Ed. Haven't had a chance. One day maybe. But if you look at the Star Wars example, that is basically the most common example that you have in the GraphQL server world. You always have like an episode, right? And an episode has several characters in it. And the character could be both human or a droid, right? So you have like humans and droid in the character, that's as far as I understand it. And both have a greeting, right? And let's say you wanted to look at that, like put that into a schema, and you might have an interface for a character, right? You have an interface very similar to what we have as a protocol, where you have your interface as a character that just defines what like that a human and a droid both share a string, right? A name as a string, right? And then you say like, well, so the droid implements the character and the human implements the character. So the second and the last type that we have here. Then you also know for the episodes that you have like Empire, Jedi, and New Hope. And then you have the input for greetings, because both like human and droid can be can do greetings, right? So if I wanted to find a single film, right, I would have the title A New Hope that I would have in here, right, which would give me back the episode. And from that, I wanted the director and the characters in the name, right? In Apollo, for example. So we're going through these 3 different libraries that are available in iOS and look how they generate code for us and how we can use that. Then if we put that into like Apollo, we would get like a huge file, or we could actually get several files if we wanted on, because we defined this .graphql file that's actually defining the query, right? It would automatically generate like the character's name and appearance in, because that's part of the schema that we gave the code generator and the query. And then we would be able to say like, well, if I wanted to make the character that I'm getting out a human, because I know it's the polymorphism that potentially like a character could be either human or droid, then I'm basically just typing my unsafe result map, which is again a dictionary, into the other type that I needed because it has the information in it. And then the result map that I'm getting from, I can typecast because I know that the type is actually matching my schema, right, into a list of episodes. It's rather bare bones, and we'll come to that in a second to like look at a comparison of the libraries. If we do the same thing in, I was one too fast. If we do the same thing in Swift GraphQL, which is a little bit more Swifty, Swift library for GraphQL implementation, we can do, we can just say we want all characters for an ID that's coming from our ID selection, and then we wanted the names, and if it's if the message that we're getting back, or if the character we're getting back is rather a droid, then I implement it with my primary function, or if it's a human, then I implement it with my home planet and give the home planet back, right? And so the code that I'm implementing from this, or that is actually like code generated on Swift GraphQL, is a lot nicer and human readable. But you see here already, like it's using codable underneath, and it's using observable object to actually look at like, I'm implementing this structure underneath my objects. That's a droid, and a droid has these different properties, right? Which are here all strings because the schema is differently defined in this example. But they're all codable objects that we have in here, and therefore, like you have the compile time type safety that, like, because the code generated like types that we code generated here, right, from our schema and our queries match together, right? And we would, if the schema would change and anything would break, and we would reference any of these droid objects or these droid properties, it would break. And then looking at GraphqL, which is the third library in our little comparison that are available on Swift and iOS, they're using a more SwiftUI-like approach. So they're using Apollo underneath as the Apollo client, which we'll come to in a second again, and the Apollo code generation, but they enhance it with the observable object and the observable with property wrappers. So if you wanted to, for example, show all the different characters or all the different characters that you have in Star Wars, right? The only thing you would need to do in your SwiftUI view, and this is where like you putting it into the next level, right? You would only annotate your views and saying like, well, I have this GraphQL property that is a Star Wars person name, right? And I have this from the Star Wars schema, I have a person and I want that name to this property, right? And then in the second part, I'm doing the same thing, but I want the person's home world and I want the name to the home. Then it would take all of your SwiftUI views that you have on your view, right? Put them together in one query. So it would automatically generate a query from your property wrappers and send them over to the GraphQL server to get back the response that you want and decode or deserialize and serialize on the other way around if you wanted to like mutate or modify anything. And you wouldn't even have to touch like any of the API pieces. Isn't that wonderful? So the result code looks the same, right? The code generated code we looked before. It's a different example here because it's hard to find like an example for Star Wars with GraphqL, but the code generation part is the same like logic following like that you have a result map, which is essentially a dictionary, and then you would typecast it. So it's using, like I said, Apollo underneath. But so coming from this example, from the Star Wars example, right? Like you are very strongly, or you can very strongly like rely on type safety at compile time because you have your schema and your query and you do the introspection between the two. And the free libraries available, like I mentioned, are Apollo, Swift GraphQL, and GraphqL. Going through these quickly, like if we're looking at Swift GraphqL, it strongly abstracts GraphQL. You almost never have to touch like GraphQL itself, right? The generated codes, this was the second example that we looked at, had very clean and human readable code, which is worth a lot, right? The nice part here is it allows you for dynamic runtime queries, right? So you would, in fact, lose type safety at compile time for dynamic runtime queries. But for example, let's think about the the fact that you could have like a search query that is user-defined parameters, and you could put all these into like the Swift GraphQL implementation that you have. It would compile or it would put together a query for you and automatically compile it, deserialize it. You don't have type safety at compile time for these like dynamic queries, but you have otherwise type safety for queries that you wrote in Swift. You wouldn't have to touch GraphQL in that case. It's actively developed, and it supports advanced features like subscriptions, APQs, and other things, which we're going to talk about in a second, or at least look at it in a second. The other thing that one of the other libraries that is available is the Apollo library, Apollo IS. Apollo is, I think, a company that spun out from Facebook, who originally invented GraphQL in 2012. So they offer proprietary GraphQL tooling that is like a little bit advanced GraphQL features and more enterprise support features for GraphQL. It's the most used GraphQL library by far on iOS. It is rather bare bones, the type safety and the code generation, as you've seen. Like I've showed you the code where we had the result map and the result map that was casted. I've worked with it in the past in a couple of projects. It works very well. It gives you all the features, and it has like works very neatly with APQ and other like automated persistent queries is APQs that Apollo otherwise offers, which is a very nice feature, but it's not necessarily the most advanced like code generation, since you can actually run in like problems with the type safety. And the last and one of the most advanced like or the most advanced iOS library, in my opinion, is GraphQL. If you look at the GitHub library or the GitHub page for GraphQL, you find a lot of examples there. There's, I think, 3 different examples currently on how GraphQL uses like the Apollo code generation, so they don't have to focus on the client portion of the code generation itself, but they add property wrappers for SwiftUI support on it, and you never really have to touch queries if you don't want to. So you have compile time safety, and you never have to touch really like queries. You only define like what your views show, and then because your schema already tells you what's available, the GraphQL knows how to put together your query for that specific view. So you like if you have like today a view that has like 5 different views, right? Your query to your server might have 5 different properties. If you have 10 tomorrow, like it's going to be automatically code generating a query that has 10, which is super nice. So it's a very interesting take on queries, and it's first class with the SwiftUI support, which I think is the future. So that's very nice to see. Before we come to an end, let me just tell you a little bit more about GraphQL. I know we've made leaps coming from REST, where we talked about like how we have different endpoints and how like we have to talk about the format, the exchange format. But there's a lot more that GraphQL can offer, right? So GraphQL also has a very nice caching mechanisms where you can have like different portions of where you can cache different portions of your query, or where you can even say like I want to rely on like for this part of the query where you have like a master detail view or a main detail view, where you can say like, well, on the main, I just want to show 2 of these properties. So you cache these 2 properties in a detail view. I want to show the remaining 8, for example. Then GraphQL can like simplify your query automatically, and you wouldn't have to overfetch like the 2 properties that you already had in there, right? Which is super nice. It helps a lot with n times n problems, where you have like one object that you need to fetch n times objects from each one of these objects that you're getting back. It helps a lot with that. It has subscriptions, so you can have like silent push notifications with secure sockets in subscription services, where you like if your user may be like changing data on your laptop or on the desktop computer, right? And your GraphQL server notices that there's a mutation, it can automatically give a silent push notification to your iOS client and establish a secure socket to automatically do the JSON patch for you and update your client without ever having manual input into that. You can have persistent queries or APQs and automated persistent queries for caching and for making sure that, for example, like certain data is only allowed in certain graph traversals and so much more. So GraphQL is very powerful and has a lot to offer. So I encourage everybody to look into it and see if it's a solution for them. I gave a talk a couple of years back, I think in 2017, on server-side Swift GraphQL, where how you can implement GraphQL, a GraphQL server on the server side with Swift, where you could combine like both languages on the same thing. I've linked it here, and I'm gonna send out the presentation or make it available after my talk. And then like the talk is from 2017, but the library is still actively maintained, which is very nice to see how you can like basically write one server in both ends, and then you can just like asynchronously resolve each of your entities and put you together your schema from an existing REST and API that you have. And that's it. So here's the QR code. If you scan it with your iPhone, and if my server still works with it, which I haven't looked at in a little bit, you should be getting a PK pass that is allowing you to like get all the information from myself, or you just make a screenshot. And if you ever have any questions, feel free to reach out on Twitter. Thanks, everyone. That's what I had. Ed, I see you're raising your hand. So
Yeah, I pass it. Ed, you can unmute yourself, but yeah, thank you very much, Florian. Well, Ed, if you want to take the first question, since you have the power, go ahead.
Thanks. Yeah, the persistence and the subscription layers, is that inherent in GraphQL, or is it part of the GraphQL definition, or is that like server implementation dependent?
It's so automated persistent queries is basically just a way of like APQs. That's what I've been talking about. You use it very often when you need to cache like very heavy responses in like a CloudFront instance or anything like it. So you can turn it on the client, and then basically like your CloudFront provider or something like that can use that, right? The difference there is that you usually all of the GraphQL queries that you do are post queries, and therefore hard to cache, right? If you put on APQs, it becomes a get query, because you can basically like just hash the query, and if the server or one of your caching servers up front knows the query, it can just respond to the query, right? So that's kind of server independent. Subscriptions you need to actually implement on the server as well as on the client. So this is in backend implementation dependent.
So it's not a requirement of GraphQL in general. So like if you had a you have a Mongo database that doesn't have live query layered on top of it, you can just use it as a data store, whereas you can add live query on top of that, then you get the WebSocket interface and all that.
Yeah, correct. There's also like very nice solutions like Prisma and stuff like that, where you can get like the whole database to like GraphQL layer with like custom definitions together and like up and running in like basically one command line tool, and then you can like start defining what you actually need and what you want to allow and whatnot.
Great.
I would look at the question on the chat, but I need to get out of the presentation because I don't see my mouse cursor otherwise.
Yeah, there are no questions yet. I mean, there's one from Nathan who is asking when are you guys watching Star Wars? So maybe we should organize a party next time you guys host that Betterment, maybe right after the meetup, Star Wars watching party.
Yeah,
9 episodes to watch, right? So it's lots, plus the side movies.
As a kid, I wasn't allowed to watch Star Wars, and as an adult, I haven't had like enough company to watch it. So one day I'll do it.
If anybody has questions, please write them down or raise your hands. I have a quick one in the meantime. You showed the schema briefly before. I was wondering, I think you alluded to versioning. I wonder how versioning works, and if the schema changes, what happens to existing clients?
I hate this question, I gotta say, to be honest, because it's the first question everybody comes up with, and I don't want to say it's a weak spot, but it's the thing that you need to make sure that like your versioning strategies are aligned before you implement GraphQL, right? You can deprecate fields and basically say like, well, this field, like if you want to take a field away, you can deprecate it, so you can discourage like clients to use it if your schema is online, for example, and then obviously see when you can deprecate it. But it's a very manual process. Most of the time, like version changes happen because you rename a field. Renaming is very easy because you can rename fields from in the schema and basically say like, well, this resolver for this field will now go to the same thing, right, in your backend code. So adding a field is rather easy. But as soon as you start versioning, right, and start to like make big changes where you want to disallow fields or anything like it, you need to talk again, like exchange that metadata with the client and start thinking about like adding like different versions to the queries that you have, right, or the schemas that you have, or then like starting to think about like how you actually version your fields individually, if that makes sense, right? Like, do you just rename them? Are you actually taking something away, or do you want the client to behave differently? So GraphQL is very good in error resolution too, because the error fields are well structured, and you know, like basically through the schema, what an error field would be able to look like. So you know how to deserialize errors, and then you need to like talk to your clients. Basically, if you're taking away a field and you're making a change that would break like an older version of your app, what would that look like, and what do you want the error to look like?
So effectively, it's on the backend team to decide. There is a way to version the URL, or you would just like
you would version usually the schema, right? Like you would not version the URL because you don't go against V1. I know that there's like bigger companies like I think Airbnb is a very good example that like has a very open GraphQL API, but then again they don't give out like their or very open like GraphQL schema, but then they don't give away like authorization tokens to actually like use the Airbnb GraphQL endpoint, but they do like versioning on the URLs. They have different schemas from different GraphQL servers, and then basically they do that similar to how REST versions their API endpoints.
Okay, cool. Thank you. Ed, do you have another question?
I do have another one. Yeah, this one's from a little bit earlier, but first off, do you have any kind of preference on which iOS library you would use?
Yeah, so at the previous job of mine, we used Apollo because we bought into the Apollo ecosystem, and there's a couple of people that I know from conferences that work at Apollo. So we used Apollo back then, which works very nicely if you have like the whole Apollo ecosystem, which is Apollo Studio and a couple of other things, but I don't want to like make advertisements for them. So I use those, but the code generation is, I don't feel very human readable, right? So like the code generation is all one big result map, and your eyes become very tired over time seeing the same thing coming over and over again. And it's not very readable, not very compact. If I would start today again and I would have like SwiftUI, I would definitely use GraphqL because it uses some of the Apollo code generation and client, right? And then also gives me the property wrappers. So if I have a SwiftUI, I definitely look at the GraphqL. If I would start over again today, I would probably use Swift GraphQL because it gives me a lot of like Swift first things. Like I don't have to touch the GraphQL queries, which works rather nice, but Xcode is not as nicely extendable as VS Code, for example. And so for that reason, I would probably use Swift GraphQL when I would be in a Swift only UI kit kind of world.
Okay, and follow up with the annually anticipated Swift data component from Apple. Do you anticipate now that maybe they've been waiting for a GraphQL implementation? Does that make sense from Apple? It's a first party solution. As opposed to like a core data replacement?
I don't think it's a core data replacement, right? Since like so many of the GraphQL libraries use like SQLite or anything like it as in like data storage underneath as a layer deeper. And you can even basically use like core data if you wanted to. So I don't think they will like first pass support it the same way. Like there was a REST client a couple of years back when I started. There was like, I think RESTful was the name of the library, that if you had like your REST schema and everything together, you could just throw it in and it would code generate stuff for you. And Apple never like really acknowledged that either. So I don't think they will go for it. And in addition to that, I do think, given that like historically GraphQL was built at Facebook, and Apple and Facebook are not best friends these days after Apple tanked their stock, basically. I'm not sure how much that will play out, but yeah, I wouldn't bet my money on it.
Guess we'll find out in 2 weeks.
Yeah.
Thanks.
Any other question? quick follow-up on what you just said, like GraphQL is still maintained and developed by Facebook. They're still working on it actively.
No, I think GraphQL itself has been branched out many years ago. So it was already branched out as its own, I think, foundation or something like that. I don't know the actual like legal term, but it's an open source. GraphQL is like indeed the language itself as well as the protocol specification is now all open source. So Facebook has very little to do with it anymore, which is rather nice. Like we're using it, or we're starting to use it on several projects now. And I've used it outside of like iOS Swift several times, which is very nice because you don't need to rely on like any kind of closed source data or closed source specifications. So everything is well documented and people can rely on it outside of the Facebook context.
Cool. All right. For those of you who missed the beginning of the meetup, well, first, thank you very much, Florian. I think we're going to wrap it up right there. And before we go into networking, thanks again for your talk, and both of you, Ed and Florian. Before we head into networking, for those of you who missed the beginning of the meetup, we're not going to do announcements because we already did them. But just a quick reminder, we have a WWDC special lightning talks next month on June 28th at OkCupid in New York. We'll try to stream it as much as possible. If it's feasible technically, we'll definitely do it. We're looking for speakers, so if you're interested in speaking yourself, please reach out to myself or to Scott through our meetup pages or to the submission form that was just posted. And that's it. We're now going to go into networking session. Scott is going to share the breakout rooms in a second. The way it works is you click on the breakout room button down there in the Zoom window, and you can join any room you'd like. Are they created yet or not?